Okay, the last section in this chapter is about area formulas. So we're going to be finding the area of these different quadrilaterals that we have. So I just want to put down all the different ways you can find area of all the different shapes. The big thing that's going to be in here is a lot of these are going to have area formulas that are base times height. The key to remember here is the height has to be perpendicular to the base. Okay, if it's not, then you can't use it as your height. So if I'm going to do base times height, this line on the bottom would be my base. This would be my height. Okay, so your height always has to be perpendicular to your base. So that's one way to find the area of a parallelogram. In fact, that's the only way. Rectangle is the same formula. So it's also going to be base times height. But what's nice about rectangles is, since all these are right angles, your base and your height are both going to be sides. Rhombus, since a rhombus is a type of parallelogram, you can use the same concept. Okay, and you can use base times height. But rhombus actually has a different way to do it also. So let's put another rhombus on here. Okay. Another way you can find the area of a rhombus is to take half of the two diagonals multiplied together. So if this is D1 and this is D2, okay, diagonal 1, diagonal 2, if I take half times diagonal 1 times diagonal 2, that will also give me the area. Okay, a square. Square is kind of the first thing we actually learn to take the area of. And all you do is you take one of the sides and you square it. Okay? Because your sides are all the same. So it's just s squared. Of course, since square is a rhombus, you could also do the diagonals. So you could do diagonals, half the diagonals multiplied together. But really, why would you do that when you can, when you can just use the sides? I guess if they don't give you the sides. So we'll throw that one in here too. Half diagonal 1 times diagonal 2. For a trapezoid is a little bit different than the rest of them. There's a couple ways to think about it. What you want to do is you want to take the mid-segment times the height. Okay, and the height is the height or the difference between the bases. So this is your height, and you're going to take mid-segment times height. And the mid-segment really is half the bases added together. So here's the more formulaic way of looking at it. This would be base 1. This would be base 2. You add those together, divide by 2, and then times that by the height, and that'll be the area of a trapezoid. For a kite is a lot like a rhombus, as we've kind of noticed looking at our flow chart on the front, because you can get to a rhombus from a kite. So a rhombus ends up having a lot of the same properties. So again, area of a kite is going to be half the diagonals multiplied together. So we got D1 and D2. And of course, triangles, we don't want to forget about those. Again, make sure your height is always perpendicular. So you want to use an altitude for your height. Okay, H must be an altitude. So we could do this, or we could come out here. This could be our height. This would be our base. But triangle, since triangle is not a quadrilateral, and most quadrilaterals are base times height, a triangle is actually half of a quadrilateral. Because if I duplicate the same triangle, okay, so if I take this two triangles and line them up. Okay, together they'll make a quadrilateral. Okay, so that means the area of one triangle is only half the area of a quadrilateral that would be made by doubling it. So that's why the area of a triangle is 1/2 the base times the height. Okay, the other thing you should be aware of is if they give you a big shape, let's say they give you a trapezoid here, and inside that trapezoid they're going to put a rectangle, okay? Well, if they shade in this trapezoid, okay, so they give you something like this, and they want to know the area of the shaded part. All right, what you're going to do is you're going to take the area of the big shape and subtract the area of the unshaded parts. So if I want to know the area of the green, I'm going to take area of the trapezoid and subtract the area of the rectangle. Okay, so because I'm taking the area of the whole thing and I'm taking away the area I'm not concerned about, and that'll give me the area of just the green parts. Okay, so that'll be a couple problems in there. Other than that, it's pretty straightforward. Just apply the correct formula based on what shape you have, and this should be fine. The other thing is if you have a bunch of shapes hooked together, you know, so maybe they put a rectangle and then they attach it to, you know, a triangle, you know, whatever, and then they can throw another shape on there. What you're going to do is you're going to find the area of each individual shape, okay, and then use that to find the area of the total thing. Okay, so if you got something like this, you'd find the area of the rectangle, the area of the triangle, the area of the parallelogram, and add them all together, and that would be the area of this entire shape.